Hey everyone, and welcome back to this class, Deep Reinforcement Learning, Deep Learning in Python Part 7. In this lecture, my goal is to give you an overview of how threading works in Python, since many of you haven't seen this before. Essentially, this example will have the same basic structure as our real example, except each worker is just going to count and print out its count, up to a global maximum. The relevant file for this lecture is threadexample.py in the A3C folder. First, let's talk about the worker class. So remember that conceptually, what's going to happen is that we're going to create multiple of these, and they are all going to run in parallel. In the constructor, I have two input parameters, the worker ID and a global counter. Inside the constructor, I'm also going to create a third variable, a local counter. So the idea behind this very simple program is this. I want to have a global counter that's shared amongst each thread. Each thread is going to run in a loop, and each iteration of the loop, it's going to increment the global counter. Once the global counter reaches 20, all the threads are going to terminate. The trick is, each worker is going to take a different amount of time between each iteration of the loop. So what that means is if, say I have two workers and they are jointly counting up to 20, then one of the workers might have been responsible for incrementing the counter 13 times, whereas the other worker might have been responsible for incrementing the counter only 7 times, but the total is 20. So that explains what we have next in the run function. The run function runs in an infinite loop. The first thing we do is sleep for a random amount of time, anywhere between 0 and 2 seconds. Then we increment the global counter. We also increment the local counter. Next, we print out the worker's ID along with its local count. Finally, we check if the global count is greater than or equal to 20, and if it is, we break out of the loop. So what might we expect when we run this? Well, let's suppose we have 8 workers. Our total count is 20. So on average, our count will go up to 20 divided by 8, which is equal to 2.5. In reality, some threads might only count up to 1, but other threads might count up to 4 or 5. Let's now go over the main part of this script. The first thing I'm going to do is create a variable called global counter, which is a thread-safe iterable. This is just going to count, so 0, 1, 2, 3, and so on. But it's thread safe, so when one thread updates the count, all the other threads will know about it. Next, I'm getting the number of available CPUs by calling multiprocessing.cpu_count and assigning that to a variable called numWorkers. Next, I have 3 main blocks. The first block is to create the workers. The second block is to start each thread, and the third block is to join each thread. We'll talk about why join is needed later. So in the first block, all I do is create a list of workers. I loop through numWorkers, so that's going to start counting from 0, and I'm going to use that as the worker ID. Each worker constructor also gets the global counter passed in. Finally, I append each worker I create to my workers list. In the second block, I create a list of worker threads. So now I loop through each worker and make a lambda function from each worker's run function. This is because I want to end up with a function that doesn't have any parameters. Next, I create a thread, and I pass in the function name I just created. The thread now knows to call this function. Once I create a thread, I call the start function to launch the thread. So that's going to call the worker's run function, but now each worker's run function is going to run in parallel. Finally, I append the thread to my list of threads. The last block we have is the join block. So why do we need this? Well, normally when you have a thread, you can think of it conceptually as sort of outside the main program. In other words, my main program will launch some thread, but it doesn't care what happens with the thread after that. So once I launch the thread, I consider my job done and I can move on. In terms of this code, I'm going to print out done at the end when everything is complete. But I can't do that because launching a thread is not the same as waiting until the thread is finished. Therefore, I don't want to launch my threads and print out done while the threads are still running. Instead, I only want to print out done when all the threads have completed their jobs. So that's what join is for. We'll demonstrate this code twice, both with and without join. So let's run this with join first. So as you can see, we print out done at the end as expected. Also note that the final count for each worker is different. That's because they're all waiting for different amounts of time. So some count up to 4, whereas others just count up to 3 or 2. Now let's run this same script without join. As you can see, done gets printed out at the beginning, which of course doesn't make any sense.